All right, folks. Well, this time around, I just wanted to run through Lab 3 and kind of give a summary of the key points there. Essentially, again, we're going through the same process of pulling an update on the repository, looking at what changes are there, looking at the updates to the project description itself, updating all of our documentation, and gradually working our way through all of the different requirements for this lab. Now, there are a fair number of them, so for this and most of the future labs, I would kind of recommend, jotting down a little checklist someplace or having a little to-do list of the different things that you want to get completed for the project before the next submission, just to make sure that you do actually get them all done. But again, that's a personal choice. So for this one, the biggest change to the project itself is that we're now supporting multiple buildings instead of just one. So when the user is running our project, they're going to type in the names for multiple building files. So there'll be one file for each of the buildings in our simulation. And so that change is now reflected in the project description. If you have a look there, again, down at the bottom, there'll be a highlight of the changes. And so when somebody's actually running our project now, they'll be giving multiple file names. Each one will have the description for an individual building. So that's the biggest project change. In terms of the requirements for the labs, we're going to be doing some more Git scripting. We're going to be doing some more creating some more test cases, so a number of different things to work on here. And again, all of the final work should be winding up in your master branch. So do your git pull instructor master to pull over the changes that I've added, and those primarily consist of adding yet another bash script that you're going to be implementing and moving that uat.sh script into the test directory. So after you do your git pull instructor master, you'll find that it opens up an edit window, waits for you to type in a commit message, and it'll store a commit for merging sort of my changes with your changes. And once you've done that, you'll see that the uat.sh has moved into your test directory. So the bash test.sh has also been created, and it's in the test subdirectory. So you'll find those things have altered once you've pulled in the changes from this week's lab. So as I mentioned, we're now supporting multiple buildings, which means that there are going to have to be some additional changes to the way the different scripts work, and I'll talk about those in just a second. We're going to make one change in the way we store our test cases, and that's related to the way we're going to be doing our test scripting in a few minutes. But what we're going to do is add an extension to the file names that we use for our different files. So we'll have the files with descriptions of the buildings, and those are now going to end in a .bld. We'll have the files for user input, or containing the user input for our test cases. Those will now end in .inp. And .exp for the expected output files, and we're actually going to be adding an actual output file with a .act in a bit as well, but we'll get there in a second. So for the test cases that you previously created, you're going to want to go through and rename those just slightly and update your test documentation to reflect the new names. I'm going to get you to expand your suite of user acceptance tests, so I'm going to get you to make sure that you've got at least 5 error handling cases and at least 5 valid cases. So, 5 cases where the user enters completely normal input and just showing that the program works as expected under different scenarios. And then the 5 error handling cases are for things like, errors in the names of the files, the name of the building input files that they provide, or actual errors within the building files, or errors in the input that the user is typing in. So those are the kinds of things we're looking at, is to make sure the program identifies and responds correctly when the user does something incorrect. All right, so those file names have changed, and the number of buildings files has changed, and so that user acceptance test script that we came up with is going to have to change as well. Right now, instead of just running our UAT and giving it the names of the 3 files, now there might be a whole bunch of building files that it has to run. So, and of course the extensions have changed. So now, what we're going to do for our uat.sh is expect that the command line arguments are given as follows. The first command line argument is the name of the user input file, so the .inp one. The second one will be the expected output, the .exp. The third one will be an actual output file, and so that's going to end with a .act. And then all the rest of them are going to be assumed to be building description files. So there has to be at least one building description file, but there might be a whole bunch. So now the uat.sh is going through and checking the parameters and saying, okay, the first one's the input file, second one's the expected, third one's the ACT, and all of the rest are building files. So, when we run it, it might be, there should probably be a / in front of that, but our UAT and then all the different files in the given order. And so now our uat.sh should be going through and making sure that each of those is a readable file. It should make sure that we can actually write to the .act file. Right? So it wants to make sure that these things exist and that we've got the permissions for them. And that there is at least one building file. Again, there might be more. The other change that we're going to make is instead of just having the script kind of run our .project and then the building files from the user input file, we're now going to store the results in that whatever file name they gave us for the actual output file. So we're just throwing in, so we're running our .project, the list of building parameters that building file parameters that we came up with, the user input file name, and then the actual, the file name for where we want to store the actual output. So our command has changed a little bit. And then what we're going to do once that has run is we're going to compare what this stored in the actual output file with what we anticipated getting in that expected output file. So again, diff is the Linux program that just does line-by-line comparisons of files and shows you the difference. So we'll do a diff between what we actually got and what we were expecting. So now your uat.sh is actually running your program and showing you if it did what it expected or not. If everything worked, then this diff shouldn't produce any output, right? If the program output was exactly what expected, then you'll get nothing here. If the diff shows anything, then your expected output and your actual output didn't match. So we're also creating a new script, batchtest.sh, and what this one is going to do is this is going to use a similar process to the recursive examples that we were looking at in the lecture, except we're just going to go kind of one layer deep. And the idea is for each of the test cases that we've got, so for each subdirectory of our test directory, our batch tester is going to call uat.sh on the .act, .inp, .exp, and building files in that directory. So it's going to go through and look for the file name, the file with the .act extension, the file with the .inp, the file with the .exp, and all of the files with the .blds, and run uat.sh on that collection. So it's going to have to build the right collection of parameters and call uat.sh. So that'll be the task for our batch tester. And again, we should have the bash skills at this point to do that one. And then the other thing that's going to take place here is we're going to impose some more structure on our directory. So what we're going to do now is create subdirectories for the different kinds of files we're working with. So we'll have a header directory, HDR, that's going to have all the .h files, an object directory, OBJ, for the .o files, a source directory, SRC, for all the .cpp files, a bin directory for the project executable. Right, so we'll have these 4 subdirectories instead of having everything sitting right in the main project repository. So those 4 will be kind of subdirectories of our main project repository now. And that means that in your .cpp files, you're going to have to modify the hash includes so that they hash include the thing that's, they include the path to where the header file is. And it means that your make files are now going to need to be updated to have the correct paths for all of the targets and all of the files that you're using. So you're moving your .h files, your .cpp files, your .os, etc., and updating your makefile, making sure you've got your hash, if not defs and whatnot, in your .h files, or using the pragma once. So you'll be going through and doing this. When you move files, be sure you use the git move command rather than just the Linux MV, because you want to make sure that Git knows that you've moved these things. Otherwise, when you push it, to me, it's going to look like you've got this old one plus a new one in some other directory. So do make sure you use git move to move those things, and update your makefile. Again, your makefile now is supposed to be based on separate compilation, right? So the kinds of examples that we've been doing in the lectures, where each individual .cpp file is compiled into its own .o, and then the executable is built from the .os, and having the correct set of dependencies and rules to make sure that it correctly recompiles exactly the portion that we want. Nothing extra, nothing missing. So, a bit of a makefile exercise in this one as well. Like I said, there's a lot of moving parts in this particular lab, so it is worth taking the time to go through and make sure you get each of the pieces here. All right. Let's see. I think that was the biggest set of items that I wanted to go through. Again, check the code standards. And this time around, that was the other thing I wanted to get you to do, was to actually go through and make sure that you've created skeletal versions of each of the files that you're implementing, right? Going through and creating, for all of the files that you came up with in your design, make sure that you've got the header file and .cpp file for each of them with the correct set of hash includes. So we've got the correct structure in place, and then in Lab 4, I'm going to actually get you to implement all of the input and error checking. So reading and checking the user input, reading and checking the building description files, and giving all the appropriate error messages and whatnot. It won't have to do anything with the data that it's reading and checking yet, but so that you've got all of that mechanical input checking stuff taken care of by the end of Lab 4. And then in Lab 5, you're going to be doing the implementation of your algorithm design to actually get this thing more or less functional. So there is the plan. In terms of, again, just a kind of quick recap of the new structure. So now in your project, you'll have a bin directory, you'll have a header directory, you'll have an object directory, you'll have a source directory, and if we list what's in there, again, any .cpp files you need are in the source directory. Any header file, a header file for each of those .cpp files is in your header directory. When you compile, it's putting the object files in your object directory, and the executable is winding up in your bin directory. So those are things to remember. And again, you're going to be updating your makefile so that it correctly uses each of those. And you're going to be updating your various C++ files to correctly include the paths to where the appropriate header files actually are. And so I do want you to go through and make sure that you get that implemented, and hopefully your make actually correctly compiles everything for those assorted .os. And you don't have to use the same breakdown into .cpp and .h files as I've used here, but whatever your breakdown actually is, your makefile should now be compiling it correctly. So those are the kinds of things to be watching for. Again, in your test directory, you've now got your batch test.sh and your uat.sh, plus whatever subdirectories you've created for your different test cases. So those are the things to be watching for in Lab 3. All right, I will leave that there.